to see. Thanks, Lisa. Within the next few years. Yeah, that's scary. Oh, there we go. So it's divided in the talk is in 4 parts. Well, that last part with websites used is just a summary of the just a couple slides that you'll see at the end. But in the beginning, we'll talk about weather and climate basics. So most of the talk will talk about different factors of the weather and climates and get you used to them. I'm sure you already have a good general feeling for things like clouds and temperatures, but we'll just rehash that for everybody. Then we'll look at products after that, like internet websites that you can use that are free, easy to use, get familiar with that. Then we can do applications like the solar eclipse in April of next year. We can look at that, and we'll look at some other things too. And if you have any questions or anything, feel free to interrupt me. So weather is the measure of the state of the atmosphere at this specific time. So it might be 42 degrees outside. You know, your dew point might be about 30 degrees right now. I think it's mostly cloudy, stuff like that. It's measurement of like the different variables and parameters of the atmosphere right now. Climate is a statistical representation of the weather. So right now it's early December. So our average high might be in the upper 40s right now. There might be a standard deviation of 8 or 9 degrees. So 75% of the time, the high might be between 40 degrees and 56 degrees or something like that. That's what climate is. You compile the statistics over decades, and then you find your different ways of measuring it. It can be median, mean, and all the different probabilities that you get with that. So for temperature, it's a measure of the kinetic energy of the air molecules. So as you add heat to air, little air molecules move faster, they vibrate faster, and they move around faster. And you can measure it with temperature, Celsius, or Kelvin. Obviously, we're in the US, so we use Fahrenheit mostly. Temperature gradients. So at the equator, the solar, let's see, here we go. Sun's rays, solar radiation, comes in very directly most of the year at the equator. At the poles, the same amount of solar radiation is distributed over a much larger area. So the rays do not as effectively heat up the polar areas, subpolar areas, even mid latitudes that we're at. They're not as effectively heated over the course of the year. So this gives you a temperature gradient in so the temperature change, and the gradient would be that it's cold in the poles and it's warmer in the equator. There's continental versus maritime difference too. So water has a very high specific heat. It takes a lot of energy to heat up water. It also takes a lot of energy to cool it down. So if you're around an ocean or around a lake, over the course of the year, you're not going to have as much temperature variation. The winters are going to be milder, not as cold. The summers will be more pleasant, not as unbearably hot. We're in the middle of the continent, so we have things like vegetation, we have soil. That stuff heats up and cools down a lot more rapidly than water does. So since we're in the middle of the continent, we're going to have cold winters and hot summers. If you're at low latitudes here, yes, there's a tilt of the Earth's tilted a little more, 23 degrees, but the sun is still pretty much near overhead at noon the whole year. And you generally have about 12 hours of sun here in the low latitudes in the tropics. So they get strong solar radiation over the whole year. So it's a hot climate. It's always, like a high of 85 or 90 degrees at sea level. And then you get your nighttime lows, and you don't have any solar radiation heating the Earth. And the Earth is just radiating energy away to space. And as the Earth radiates energy away to space at night, you're going to cool off because you have no radiation from the sun. So in the tropics, it's going to be like 85 degrees for a high or something like that at sea level, and then 70 degrees for a low every day, pretty much the whole year. So your seasonal cycle is that there isn't really much of a change in temperature over the course of the year, but most of your temperature change is your change from day to night. So we call that like the diurnal cycle. So the diurnal cycle there, your change from day to night temperature is greater than your seasonal cycle. Well, you go up to the mid and high latitudes up here, and things change a lot. In the summertime, the North Pole is in the northern hemisphere summer, so June 21st, the North Pole is slanted towards the sun. So if you're at the North Pole on June 21st, or if you're north of 66.5 degrees, you're going to have 24 hours of sun. Here in St. Louis, you might have like 15 hours of sun. Oh, you're okay. And the sun in summertime, and you're also going to have sunlight over 12 hours a day in your summer hemisphere. So that's going to warm it a lot in the summertime. Well, then if you're in the winter, and if you're in these mid and high latitudes, if you're at the poles, you're going to have no sun. So the Earth's just radiating away energy to space, so it's getting colder and colder. Here in the mid latitudes, you might have 9 hours of sunlight on the 21st of December. But the sun's really low in the sky. Like it doesn't even get to 30 degrees above the horizon. Whereas if you're overhead, you're 90 degrees. So the sun is very low. In the wintertime, those rays are really hitting at a very oblique angle. So it's cooling off a lot. So in these mid and high latitudes, your seasonal cycle is greater than your diurnal cycle. So, our change from in St. Louis, so it's about 18 to 20 degrees. It might be 70 for a high or 50 for a low in the middle of spring and fall. But if you go from winter to summer, like summertime, your average temperature might be about 80 degrees if you have about 70 for a high, and 70 for a low and 90 for a high. And then in wintertime, it might be about 30 degrees for a 40-degree daily high, 20-degree daily low. So you have a big change, about 50 degrees or so, between winter and the summer. So the seasonal cycle here in St. Louis, we're on this mid-latitude range, and it's a lot. Yes. Oh, stay near the speaker. Sorry. Oh yeah, use the laser pointer. Thanks. I'm used to wandering around. Oh, thanks. I'm sorry. I get to like teaching mode and I forget that I've never taught online. I always forget, and it was all pre-COVID. Sorry about that. And then also a big thing in the wintertime too in these mid and high latitudes is you get fronts, and those change the temperature a lot, and you generally don't get those in the tropics. For water vapor content, we generally call that humidity. And this one is, in my opinion, the most difficult variable to understand. I've heard millions of people say it's 90 degrees outside with 90% humidity. Problem is that's really rare. That almost never exists anywhere on Earth. The record dew point is like 94 degrees in the Persian Gulf. And because the sea surface temperature was 96 degrees in the Persian Gulf over open water, and that's the warmest sea surface temperature, and then the dew point kind of follows that because there's so much water to evaporate. But with the dew point, every 20 degrees Fahrenheit, you double the amount of water vapor the air can hold. So if it's 40 degrees out right now, and you go to your dew point's 40 degrees, the air would be saturated. But if you go to like 60 degrees, it doubles the amount of water vapor the air can hold. And then if you go to 80 degrees, the amount of water vapor the air can hold doubles that. So it's 4 times that of 40 degrees. So it's an exponential increase for water vapor. So it's not linear. And I think that's just an inherently difficult quantity to understand. Other than if the dew point is above 70 degrees Fahrenheit or so, pretty much everybody is going to consider that to be muggy. Precipitation. Precipitation is also slightly difficult too, because it's not like temperature. It's either precipitation, it's either precipitating or it's not. It's kind of like a 0 or 1. It's kind of a binary thing. And precipitation can be very spotty. Like in the summertime, you get thunderstorms, and 30 miles away from the thunderstorm, you may not get anything at all. But in the wintertime, you don't have that instability, and things are a lot more flat and horizontally uniform. So precipitation patterns in the winter, they tend to be more uniform, slowly varying, also kind of more showery. Like if you want a soaking precipitation, you want to get that. Wintertime is the ideal time to get that versus the summer. So hopefully with this El Nino we have this winter, hopefully we can get some more precipitation, El Nino and La Nina. We don't have that great of precipitation correlations here in Missouri, but in Illinois, but sometimes the summers can be on the wet side. So that'd be ideal if we get some more moisture these next few weeks. For part of the talk we'll talk about, precipitation can be important with snow. And for high latitudes and altitudes where snow cover is a major factor over the course of the year, there's a lot of variability. So if you get 50 inches of snow one year and your average snowfall is 100 inches a year, then another year you might get 150 or 200 inches. And if you have things like plants that depend on when the snow melt is in these cold northern type climates or subalpine or alpine climates, then the blooms for the spring ephemerals, they can be off by several weeks and sometimes even months. So these cold climates, it's good to know the climatology and how your winter is doing if you're going to plan a trip. Wind, we won't talk about too much about wind. I know photographers can really enjoy wind sometimes. And over the water, you have very little surface friction, so that doesn't impede the wind much at all. So over the oceans and over lakes, your wind speeds are high. Prairies also have relatively low surface friction. So whenever you go out to a prairie and you want to photograph a little plant that's very diminutive or a tall plant that doesn't really have much resistance to the wind and the flower bounces around in the wind, pretty much whenever you're at a prairie, that'll happen, it seems like. Then there are clouds, and we'll talk about clouds with astrophotography. In short, if you're in a desert, it's especially in the Southwest U.S., it can be a good spot because you don't have a lot of clouds. There's not a lot of moisture. Also, things like population density. If you're out in like Arizona or New Mexico, you get away from big cities, and generally you don't have many people. So we will talk about clouds a lot more in depth. Any questions so far? So this is the annually averaged temperature for the US. And you can see as you go north towards North Pole, away from the equator, it gets colder. So up in Minnesota, over the course of the year, it's going to be a lot colder than down on the Gulf Coast. Also, you have things like higher altitudes. As you go up in the atmosphere, the pressure lowers. And as a result of that lowering pressure, air expands as you go up and the temperature drops. So as you go up in altitude, you get these colder climates in the Rocky Mountains, Cascades, Sierra Nevada, and those will also affect your climate. This is annually average precipitation. The biggest single takeaway I would say is that as you go east in the US, it's generally wet. As you go to the west, it's generally dry. There's a couple factors that create this. You have a cold currents coming out from Alaska on the west coast, and it goes down south past Washington and Oregon and California, and that sets up kind of a stable regime. And there's not a lot of precipitation with that in general. And then on the east coast, you have the current coming from the equator towards the poles. So you have the Gulf Stream generally going northward, transporting a lot of warm, moist water, that will give you warm, moist air above it, and that generally helps to produce rainfall. Also with mountains, they generally create a ridge over the mountains and a trough downstream of the mountains. That also enhances the precipitation on the east side of the US, and it's reduced in the west. And you're gonna say, well, what's going on in the west here? When you have these mountains, you have all these precipitation maxima. That's because when air goes over a mountain, it has to go up above it. And as it rises over the mountain, it'll condense and it'll form clouds. Then eventually those clouds are gonna build and they will create a lot of rain and snow. So when you're in some high elevations out west, you will get a decent amount of precipitation. A lot of it is snow as you go in these higher altitudes. Sure.
What kind of situation in parts of the country, parts of the world, and stuff from the coastal area around you?
So monsoonal climate, really good for that. We have a weak monsoon here in the southwest US, but if you go into like India and southeastern Asia, they have a really strong wet season. Generally, for India, it's in the summertime, like June and July, and the winds come out of the south, out of the Indian Ocean, and it just dumps rain. And then in the wintertime, the winds come out of the north there in India, and it's dry as a bone. And then other parts of Asia, the monsoon can be switched. But in those conditions with monsoons, sometimes the monsoon comes when you're, sometimes it's really weak, and sometimes it's super potent, and it depends on other atmospheric factors. So if you're in a monsoon climate, which the southwest US gets a little bit of that. For instance, like the southwest US monsoon is generally, I would say, Arizona, New Mexico are the big two states for it. A little bit of West Texas, like Big Bend National Park, some of Colorado and Utah also get the monsoon. And if you get a good, strong summer monsoon, like late June, July, August, first half of September, then you can get a lot of wildflowers blooming in these deserts here. So that's kind of an ideal thing. I have a friend from New Mexico, and he says, you know, the monsoons don't always come very strong. So when you see some of these plants blooming in the mid to late summer, it might be 3 years until you see them next. So that is something to consider in a climate like that. Sure. Good question. So in general, areas like Missouri and Illinois have been getting warmer and wetter with the climate. So our climate in Missouri, I would say, is kind of becoming more like Arkansas or Kentucky over time. And I'm not exactly sure about some of these other places in the US, other than it's generally getting warmer, most of the areas. In the West, we've done a lot of kind of terraforming and our fire, what we've done with fire practices, we've generally kind of made the West drier. I don't know if that will continue in the future or if hopefully we can get back to more sustainable climate for the West because the West is not in great shape right now. Oh, I'm sorry. Yeah, I forgot. So the question was, what is the climate doing for like St. Louis area or for the map? And for St. Louis and Illinois, it's generally getting kind of wetter and warmer. It's generally, I'm sorry, warmer for most of the U.S. And unfortunately, it seems like a lot of the West has been kind of drying out. This past winter, we did have a very wet winter in the West. There's several problems happening in the West, like it's generally too dry of a climate to sustain the millions of people that we have living out there, especially in states like California and Arizona, where we have several million people, or in the case of California, tens of millions. And we're draining the aquifer a lot. Aquifers a lot. We're draining the Colorado River a lot. And even with this record wet winter, places like Lake Mead only recharged a few percent, which is just not sustainable. So that's not a good thing. If we look at dew point, this is annually average dew point. So this is like moisture over the course of the year. It kind of shows the seasonal cycle like temperature did, where it's drier and colder up north and kind of warmer and wetter down south. We're going to look at July in a minute because the seasonal cycle kind of dominates, where it's the seasons dominates this dew point signal, and that's not always the case. The dew points are really low over the Rocky Mountains. It's not because it's dry here in Wyoming and Colorado, in eastern Idaho. That's because it's cold and this is snowpack generally for most of the year. Now over here in eastern and central Nevada, that's dry. So that's just desert. So these signals out west are not necessarily the same in all places. Here in Nevada, it's desert. And here in the core of the Rockies, these low dew points are due to it being very cold and snowy. If we look at July, so now we're in the middle of summer. July for most of the US is its hottest month, most humid month. You see these 65 and 70 degree dew points basically over most of the eastern and central US. So the eastern half of the US is just miserable. Not very fun to do a long day outside in July. It's always nice to try to get the mornings in the eastern US. In the West, it's a little bit different. There's some arid and semi-arid area with these lower dew points. And then again, in the Wyoming, Colorado, eastern Utah, you're gonna get with these very low dew points, this is just due to this being subalpine and alpine type climate. Whereas here in Nevada, it's gonna be just because it's a desert. This is wind speed over the course of the year. Along the coast, the winds are really high. So if you're trying to photograph a puffin over the oceans, beware that it's going to be windy. Also over the plains, it's windy because it's flat and pretty uniform there. So you get high winds over the course of the year in the prairies. Southeast US, you have a lot of trees. Also in the West, so it's kind of low. Generally, winds are kind of low in the West too, because you have a lot of this heterogeneous topography where you have mountains kind of coming all over the place there. But if you're on a mountaintop, this doesn't show it very well. But if you're on a mountaintop, you're going to be exposed to the atmospheric winds pretty well. So if you're trying to do photography from the top of a mountain, it's going to be windy. It can be nice in that you don't have a lot of water vapor above you, but beware of the wind. So over the course of the year, There we go. This is mean sky cover and my mean clear sky cover days. So over the deserts in southern Arizona and as well as southeastern California, you have over 180 clear sky days there. So obviously, if you have some astrophotography that you want to do over the course of the year, Southwest US is great, especially if you can get out in the desert away from people where the skies are dark. There's not a lot of water vapor too, and that's great for things like atmospheric seeing. Water vapor does a lot of crazy stuff in the atmosphere, and it kind of makes everything unpredictable. But if it weren't for water vapor, weather would be very boring. Over the course of the year, you can see these cloudy and cold climates over the Northeast and Great Lakes, as well as over Washington. We will look and see Washington actually clears out really nicely from July through September. So that can be a nice time to go up there if you have stuff that you want to go and see or photograph. So we have the basics down, so we'll start to move along a little bit faster now and look more at slides. But for weather basics, a few more things. Try to use good sources for websites. So for a few days out, like less than 72 hours, I would say that's when to look for precipitation. Like you can look at precipitation forecasts 5 or 7 days out, and that's great, but always try to check within 24 hours. Because precipitation is really nonlinear, really hard to forecast. Weather.gov is generally a really good source for it. For a couple of weeks, a good one to use can be cpc.nsup.noaa.gov. And again, all these websites will be rehashed at the end. And since this is being recorded by Lisa, you can always access this online too on the Witness site. CPC does a good job they have 6 to 10 and 8 to 14 day forecasts. They show you if it's going to be wetter or drier than normal or hotter and colder than normal. So if you're going to go out for a trip for a week or two, that's a good place to check and see what your general weather conditions are to expect. Especially if you might be like driving to the Southwest US and going from site to site like Ted does with his beetles and other insects. So that can be a nice site to go and check before you end up going on the trip. Prevailing patterns, these can be predicted sometimes months in advance. So ENSO is El Nino Southern Oscillation. It has a plus phase, a warm phase, El Nino. That's what we're in right now. Negative phase, cold phase, and that's La Nina. So we're in a warm phase right now. We're in El Nino, moderate to strong El Nino. It should continue through at least March or April. And it has some correlations with the weather patterns globally. So this is the heart of El Nino. It's named, so it appears in the winter. El Nino is the Christ child. So in December, around the 25th of December, I forget if it's Peruvians or Ecuadorians, somewhere in the Eastern Pacific. They call this the Eastern Pacific, even though it's the Western Hemisphere. The natives from hundreds of years ago discovered this or realized this phenomenon was occurring, and the temperature of the ocean would get warmer around Christmas time, and that would change the weather. So that's the source name for El Nino. And what would happen is in the tropics, you generally have these winds out of the east. They call them the trade winds. And the trade winds will end up blowing the water off the coast of South America towards Indonesia and northern Australia. And when you pull this water up, this ends up upwelling water from below. So this water down here, this deeper water, doesn't see the sun, so it's really cold. So this upwelling creates colder water over South America, and then the water ends up piling up and then downwelling in northern Australia and Indonesia, and that ends up warming the water there. When these trade winds out of the east, when they weaken, then that upwelling off South America weakens, and that warm water starts to move east in the Pacific Basin. And when that happens, the rain that generally thunderstorms like this warm sea surface temperature, the thunderstorms will migrate east with it. And then that'll change a whole global circulation of the atmosphere. And then these changes affect the weather across the whole world. So for El Nino, which we're in right now, these are the general correlations that you can see for the winter time. So in the Gulf Coast, it's going to be, it should be wet and cool winter. And we'll talk about it as long as we have enough time briefly, but later on. But places like Big Bend National Park, which don't always get the most amount of rainfall, hopefully they'll have a good winter. Maybe they'll get a good spring bloom there next year. It should be kind of a dry, warm, especially warm winter for the Northwest US. So places like Washington and Montana might be a little low on their snowfall. So if you're going to be out there, the wildflowers might be a little bit ahead of schedule, or if you have insects or any of that concern. One thing to notice with this is that most of the world doesn't really have a very strong correlation here. So there's a lot of stuff going on in the weather. It's not everything is El Nino and La Nina. Like in St. Louis, for example, you don't see anything really showing up here. So we have a weak correlation from El Nino and La Nina, and we get a lot of other factors influencing our weather. So now as we go to climate, we've established a lot of these things. It's colder as you go towards the poles, warmer towards the equator. Let's see. So if we're going to use climatology for planning, monthly averages are really good to know. If you look at a website and see, generally it's going to be, 40 degrees for a high and 20 degrees for a low. Where you go, and then you can say, okay, I'm going to bring some pretty heavy clothes wherever I'm going. It's also good to know standard deviation. So if you're going in Bismarck, North Dakota in October, it could be really nice. You could also get snow because there's a big standard deviation there. So it's good to always keep in mind how the weather can change. Some places are more consistent than others. Like if you're going to South Texas in the summer, it's going to be hot. For snowfall and standard deviation, we talked about this a little bit. We will talk about it more. If you're in those kind of northern climates or subalpine climates with a lot of snow, you have to pay attention to that. That really affects your bloom time. So here's St. Louis climate. This is what I would call a warm mid-latitude climate. You can see over the course of the year, there's a big change between summertime and wintertime. You also notice these blue lines around these kind of blue contours, I should say, around the low, and these red contours around the high line. They're kind of broader and more expanded in the winter because we get a lot of fronts in the winter. So our temperature in the wintertime, it varies a lot because we're getting cold fronts and warm fronts. And that's really changing what the temperature is like outside. So you can go out in December, January, it can be 0 Fahrenheit one day. And then a week later it can be 60 degrees, or it can be even sooner than that. But the point is, in the winter, our temperatures kind of go all over the place. And then in the summer, you'll notice these standard deviation lines and 2 standard deviations are a lot thinner. That's because summer, it's generally pretty much just hot. Your fronts are weaker. Sometimes it's nice and mild if it's a little cool, but you generally don't have as much of a deviation in the summer because you're not getting those powerful fronts. For precipitation, it's a little bit wetter in the spring. There is a lot of variation you can see in with these contours around the temperature. And there's not really well-defined wet or dry season. In Missouri, for precipitation, it's all over the place. Just because it's April or May or June doesn't necessarily mean it's going to be wet. I mean, look at this year. Our April, May, and June were not wet months at all. And you can get precipitation in St. Louis pretty much any time of the year. It can be heavy any time of the year. It can be light any time of the year. It really depends on what's going on. We have a lot of different ways to get precip here, and none of them always predominate. And then this little dash line of snow. Snow is not really much of a annual factor for St. Louis. We get snow and have snow cover for maybe 2 weeks out of the winter. It's really more of a curiosity for our climate than it's anything meaningful. And our snows are generally November through early April. Now we'll look at a place in the US in which the climate, I would say, is about most different than St. Louis, and that would be Miami. And as you get down into South Florida, you're in the outer fringes of the tropics. So this is a tropical savanna climate. And what it has is the temperature doesn't define it as much as the precipitation does. So as you get in the tropics, the temperature is always warm. And they generally use wet seasons and dry seasons to define the seasons versus winter and summer, since you're not really looking at changes in temperature, but you're looking at changes in precipitation. So in Miami, from November through April, you're in dry season. And then as you go from May through October, you're in the wet season. And then you can see the seasonal cycle is a lot smaller. They do get fronts in the winter. So you can see these contours with your standard deviation in temperature expands a little bit. You get cold fronts that actually make it down through Florida, South Florida in the wintertime. But most of the year, you don't really get much cooling or heating from fronts. And generally, it's that daily low and daily high that kind of predominate the weather. Okay, now we'll start to move into a little bit more interesting stuff. This is this is average cloud cover for April from one of the satellites. So it's 21 years, so it's pretty good climatology. Blue, maybe that's a little counterintuitive in the sense, but blue means it's blue like the sky. So it means blue means few clouds and red means a lot of clouds. So this is the month of April. Next April, we're gonna have a total solar eclipse just south of us. So if we zoom in on it, we can see on average in April, it's gonna be driest for the strip of totality and clearest in northern Mexico. I'm not sure how safe some of these places are to travel. But if you don't want to go to Nova Scotia, not that it isn't safe, but it's obviously really cloudy most of the time in April. My plan here would be just to stay in St. Louis and hopefully drive to Indiana or Arkansas or somewhere if it's clear. If you remember early April, we get a lot of fronts. So it can be cloudy here and it can be clear a few hundred miles away. And if it's cloudy here, hopefully it will be clear a few hundred miles away. If we look at our mean cloud cover over the course of the year for the US, you can see changes with each season. The Southwest US and the deserts, obviously that's your best area over the course of the year. But there is variability, like if you're in July here, you've got the monsoon going on. You can actually see that it's kind of red here in Arizona and New Mexico. That's because you have the monsoon going and it is generating clouds in that area most years. In July, if you look at the Pacific Northwest, it's actually a really good time of the year because it's clear there. So if you want to like go to the Cascades, and say you want to catch like a wildflower bloom like in early or mid-July, you can have really nice weather there. It can be really pleasant and a nice time to get away from St. Louis in July since it's hot and miserable most of the time. October is on average the clearest month for most of the US. And that's because the sun's getting weaker in the middle atmosphere. It takes a little bit longer to cool down than near the ground. The ground heats up and cools off rapidly, especially if you're away from the water. And that creates a stable atmosphere in October and early fall. And that can be a good time for astrophotography around here. So this is another look at clouds. And this would just be the number of clear days. Again, we are going by season here. So we have January, April, July, and October. And you can see that in the winter time, for the northern 2/3 of the US, winter, first half of spring, it's pretty much kind of a cloudy, overcast, stratocumulus, in my opinion, kind of depressive climate. But that prevails this time of the year. You do get fronts and you do get clearing at times. But you can see in the summertime, generally you get more clearing and early fall, especially in the western US. This is wind speed for the seasons. So this top left again is January. Top right is April, July, and then October. So winter and spring can be, you get strong fronts that time of the year. You get high winds on. So if you have some photography project that can happen any time of the year, summer and early to mid fall are kind of your ideal times for photography. Obviously, if you're in the plains, it never really gets that low, and good luck. But there are parts of the U.S. like the southeast U.S. is it's pretty calm there. A lot of times they get part of the Bermuda high over the Atlantic too in the southeast. So generally you don't get as high of winds there. For thunderstorms, the southern and eastern U.S. is generally your maximum. You don't have as much stability in the northeast, and you don't have as much instability. It's a more stable climate in the northeast, as well as in the west. This is hail to the lower right. You can see in the plains, kind of the traditional tornado alley. You get a lot of hail days. Yep, Oklahoma, exactly. And curiously, also here in over the Colorado Rockies. So if you get thunderstorms here, remember you might be at 10,000 feet. So the hail doesn't really have that much time to melt. It's going to be cooler that high up. So if you're doing a hike in the Rockies in June, July, or August, try to go in the morning because you might get afternoon thunderstorms and you don't want to get lightning and hail if you're on a mountainside and you don't have, you're pretty exposed. So now we're looking at snow cover for this slide. For under 24 inches of snow, so kind of the southern periphery of the snow, snow doesn't factor in much to the climate. It's just kind of there and it melts. When you get to more like 36 inches or 48 inches or more, then snow really starts to become part of the seasonal cycle. And you have, from one winter to the next, you might get, 40 inches one winter, and you might get 80 inches another winter for snow. And when you start getting that kind of snowfall totals, it's going to linger into the spring. And when it melts is going to be a big influence on when the plants and the insects are going to follow after that. So knowing how much, following the snow and knowing how much it changes in these northern and cold climates is really important if you plan to do trips out there. This is the number of mean freeze days, freeze-free days. So in St. Louis, we have about 6 months of a growing season. where there's in-between freezes. You go into the Rockies here and it drops to 3 months or less. And in these subalpine and alpine climates, a lot of times you'll have a bunch of plants blooming together, which you normally wouldn't associate blooming together. But once they start growing and blooming, they don't have a lot of time. So they've got to produce and produce quickly. The interesting thing about these colder climates is that the spring is typically delayed a lot, but the fall does come early, but it doesn't come as early as the spring is delayed. So it's kind of this asymmetric quality going on in these cold climates. Like, for instance, if you are going to see Calypso bulbosa in bloom, if you're here in coastal California, it might be blooming in February. You know, if you're up in coastal Washington, it might be early May. If you're up in Colorado in the Rockies, it might be mid to late June. So that's, you know, a 4-month span between when it's blooming in those climates. But if you're going to see a Spiranthes or a gentian, it might be blooming here in these high altitudes in August, maybe August 15th. And then if you go into the Southeast US, it might be October 5th. So you might have like a 6 or 7 week change, which is much less than a 4-month change. So the spring is really highly variable. In the fall, kind of comes in more suddenly, kind of comes in more uniformly. This is Doppler radar. For Doppler radar, I use radar scope. I paid for it like 10 years ago. It was $10. I don't know if it's still $10 or not. It was a one-time fee. This is great because it's a really good radar. You can animate it on your phone. If you're, it also shows your location. So I took a picture of Las Vegas. I wasn't there, but if you use the app, it shows you where you are. So it'll put this little blue dot, but it's not, in this case, I didn't show that. So the radar site here is this little black circle that's been crossed out because the returns are kind of messy sometimes right by the radar. But how to read a radar, so north is up, south is down, to the right is east, and to the left is west. So it's like if you're looking down on Earth from space. So if we look at this, Nevada's kind of in the northwest side, and the southeast side of the screen is Arizona. And you can see the heavy precip, heavy rainfall in this case, maybe thunderstorms, are these highest returns to the radar. So it'd be your oranges and your reds. So you don't want to be out hiking in a thunderstorm. So if you have this app, you can see when the rain's coming in, and you can push a little blue button to see where you are relative to the rain. It's always great to have, if possible. Another way we can look at Earth is satellite. So this is visible satellite. So this is basically kind of like if you're looking at Earth from space, and you need the sunlight to see clouds. So you can only see visible satellite during the day when the sun's above. So that's a drawback. You can only see it about half the day, half of the day-night cycle when it's sunny. And so this would be a hurricane, and then this would be the eye there. So this would be what you would generally see looking at space. Well, what about when it's nighttime? When it's nighttime, we can use infrared. You can use infrared any time of the day, but an advantage is you can obviously use it at night. The problem is that it's not perfect. Like you're looking at brightness temperatures from clouds, so we're looking at emitted radiation. And so clouds that are high, or like thunderstorm cloud tops or cirrus clouds, those high wispy ice crystal clouds, they radiate a very cold temperature, so much colder than the surface of the Earth. So they show up really well on satellite. Low clouds like stratus clouds, fog, they're closer to the ground. They emit at about the same temperature as the ground. So you don't always see low clouds on infrared satellite. That really stinks because if you're trying to do any type of photography, if you're trying to do any astronomy, even if you're trying to do just birding or botany or for bugs or anything, I mean, if you have low clouds, if you have fog, you're not going to be doing very much. So there is a way around this, and you can look at surface observations. And again, I haven't been going over all the websites. They'll show them at the end, and again, it's recorded if you ever want to re-watch this all. But for surface obs, low clouds are in these pink and red and blue dots. And so even if this doesn't show on satellite, you can look at these surface reporting stations and they'll show you that they're clouds. So if you're wanting to do astronomy and you're going to drive an hour out to Danville Glades and you want to make sure there's no clouds there, you can look at surface observations and they can tell you whether or not there are clouds or not. So now we'll go into the forecast mode. So not only looking at things in real time, but how you can try to predict things so that when you go out, it can help with planning. This is a model. This is my favorite model, and at work, my other meteorologists, their favorites too. This is called the GEM model. It's out of Canada, and these speckly clouds are low cumulus clouds, and then these kind of wispy clouds are the high cirrus clouds. And this is a cloud cover plot, so you can see that it's clear over much of the country, including Missouri. And this can be nice because you can look out, a day or 5 days and see what the weather is going to try to be, what hopefully the weather will be like, so that if you want to schedule a trip that is dependent on light levels and clouds, this can give you some good guidance to help determine when that time would be. Another way of looking at clouds, this one's a little bit more intense. So we call this a log P skew T chart. And as you go up, this would be like going up in the atmosphere. So it's like going up vertically. So the top of this would be like 50,000 feet in the atmosphere. And then as you go from left to right, you're looking at temperatures. So -45 Celsius on the left and 50 Celsius on the right. So very cold left, hot on the right. And you're looking up in the atmosphere, and this blue curve is temperature, and this dashed curve that kind of waves in and out here is dew point. And when that's near the temperature, that means the air is near saturated, and that means you're probably going to get clouds. And so here we have clouds at 2 levels at about 12,000 feet, and again at about 35,000 feet. So this will tell you what altitude the clouds are at, because you don't necessarily know what altitude they're at in this plot. This is just a model plot showing clouds at all levels. But if you zoom in, so this is KBIL, this is Billings, Montana, you can see that you're going to have multiple cloud decks here. And that can be helpful because low clouds generally are not our friends for things like astronomy, and low thick clouds generally don't seem to be very good for photography either. Other products too, this is Climate Prediction Center. So this is the 8 to 14 day temperature outlook. So this was issued the 18th of August, 2023. If you remember, the end of August was super hot and humid. We had 3 consecutive days in which the dew point was 80 or above, which is actually a record. So this verified pretty well. It was a hot and nasty end of August. This is a graph that shows daylight and nights. So you can do this at timeanddate.com. This is pretty cool because if you're wanting to see like a meteor outburst in another part of the world, you can figure out when nighttime is. Like they divide night, and you have different twilights, and then after astronomical twilight ends, it becomes night, and before astronomical twilight begins, it's night, and that's that darkest contour. And this can be really helpful for looking at day and night time here. Like if you want to do the Geminid meteor shower, which is December 14th, you can see day and night then too. That's an interesting meteor shower because it's actually best kind of in the middle of the night around 1:45 a.m. if there's no clouds or no moon. So that one doesn't peak before morning twilight starts, which most meteor showers do. But that one's a little bit odd. But you can see there's this discontinuity here for Canberra, Australia. That's because they're going from their like daylight saving time to standard time, and then back to daylight saving time later in the year because their winter and their summer are reversed. And then this is a climatological, a climate plot, I should say, of the different climates over the globe. So a pet peeve of mine and most meteorologists is that you'll watch like Blue Earth or Planet Earth or something, and they'll say polar deserts, and they're not. The poles aren't really deserts; they're ice caps. You have precipitation frozen on the ground. That's not a desert. Deserts where your evaporation exceeds your precipitation, so you're not going to have any precip on the ground. It's going to be bare soil. So in gray, you can see the polar ice caps. This pine green is aptly colored because that's your northern boreal forests. Blue is, these shades of blue are your mid-latitudes. They bring up subtropical in this green, which I really disagree with subtropical going that far north because I don't consider Arkansas subtropical at all. The winters are way too cold for most subtropical fauna and flora there. I would generally cut off the subtropics more towards the Gulf Coast. And then you can see tropical savanna in this kind of lightish blue, and then your rainforest, your tropical rainforest are around the equator. And then you get your deserts in red. So this is pretty cool because it shows you all these different climates on this plot, and it can kind of give you an idea of what to expect. Mediterranean climate is this yellow, which also appears in California because they have a similar ocean temperature going on there. And then you can see in areas of mountains, sometimes you get bunches of climates. They're really stacked and you have to kind of zoom in, like around the Andes here, you have just tons of different climate variations as you go up and down altitudes there. Okay, another example would be, we'll start to get more into applications. So let's say you want to go and see Cypripedium candidum, the small white lady slipper. It seems to bloom a lot of times around April-May border. We'll say it's 9th of April, 2017 for this example. So if we go to this website, we can see what the temperatures were like. Obviously, if it's the 19th of April, you wouldn't be seeing this data afterwards, but you can see it's been a warm April, maybe like 5 or 6 degrees above average. You would think that would probably put the blooming season a little bit ahead of time. So you'd say, hey, maybe it might be blooming in late April this year. You can also go to this website and see how the temperatures have been for the season, for the months, and compare them. You also see that in 2017, March was also 5 degrees above average. So it's been a warm March, been a warm April. If these things are going to bloom in April-May boundary, I would say it's probably going to be towards the April side this year because it's been a warm spring for 2017. You can also use other sites. You can also use things like iNaturalist and iDigital Bio. iNaturalist wouldn't be great for this particular species because it's blotted out because it's not common in Missouri. But iNaturalist and iDigital Bio can be really nice for looking for bloom times and observations of different plants and animals. We'll use another astronomy example. So meteor showers. So in November 2034, there's going to be 2 outbursts of the Leonid meteor shower. Between 1998 and 2002, they had several meteor storms in which there were 1,000 or more meters an hour visible for about 5 or 10 minute spans. November 2001 was cloudy here, of course, which there was no moon. It was a spectacular outburst, like 2,000 meters an hour. And I think it lasted for about 20 minutes and we were overcast. 2002, we also had a similar meteor outburst. It was about the same intensity. It was a little bit shorter. We had a full moon, but it was still really cool. So in November 2034, the moon will be out of the way. And there's actually 2 outbursts in consecutive nights. And they generally follow the strip of latitude, the strip of longitude. This isn't perfect because it's November, so twilight's going to linger a little bit later. It'll be nighttime a little bit longer further north here, so they could still be a night here in Northern Europe. And daylight's going to come a little bit earlier down south because we're in November and the sun's up more in the southern hemisphere. You can see here in blue areas with more clear skies, Western Sahara. Unfortunately, it's not a good country to travel to if you're an American. So we can look at other places too, possibly like Portugal or Senegal. And even actually, if you can, we can't zoom in on here, but there's these microclimates here in the Canary Islands. They actually have an observatory in Tenerife, in the Canary Islands. And they're kind of volcanic islands, and you get above the trade wind inversion and it gets clearer. So that might be a good area to go in November 2034 and hopefully see hundreds of meters per hour in consecutive nights. Greenland's also a possibility, but it's not very easy to get to. Another travel you could do is say you want to see aurorae. If you look in cloud cover plots, a lot of these northern climates, polar climates, are generally cloudy climates, so that doesn't help. Aurorae are generally most frequent around the equinoxes, so late September, late March. Aurorae also are more frequent when you're near solar maximum. That should be 2025. So for the next 4 or 5 years, we should have a pretty active sun. It's definitely active right now. If a good place where this all lines up is Alaska. You can see here in March, it's generally clearer over these mountains, which is unfortunate because that means it's cold, especially as you go higher up. But like if you look at Fairbanks and just northeast of it, you can see there's a nice, relatively clear skies there. So if you were to go at Fairbanks in March, and probably try to time it so that you're near new moon, you don't full moon if you're trying to photograph aurora. That could be a good bet if you spend several days there. I wouldn't just go all the way out there for a day or two. I'd definitely try to get several nights there. So if you're in a cloudy pattern, hopefully it changes in a few days. If you look at standard deviation with temperature, it's kind of all over the place in March. I mean, it's cold. You know, it never is really that warm in March. So you can expect anywhere between -30 and 45 degrees. So probably bundle up. You can see the precipitation. It's mainly in the form of snow in March. So you're probably going to want to bring some good heavy gear there in Alaska. You can also look at weather models if you're there in Alaska, and these are 2 different ones, and see where it's going to be clear. This will obviously change from 1 hour to the next and from one day to the next. In this case, it shows less clouds over southeast Alaska here. And again, on this one, this other model here shows southeast Alaska, but it's just one time clouds and weather systems move. Another personal travel you could do We mentioned this earlier, like if you wanted to catch a good wildflower bloom in Big Bend National Park, it might be this April and May, we'll see. If they end up having a wet winter, it also is a little cool, so it might delay the bloom slightly. You're gonna be drier probably in the Northwest, so your blooms might be reduced, or they might be a little, I'm sorry, that's warm, that's not dry. So they might be a little early in the West too, although a lot of times it is also drier in the Northwest there too, with an El Nino. This is our winter forecast with the El Nino. So in the West, moisture is more of an issue than the East. The East is generally wet most of the time. So blooms are a little bit more dependent on moisture in the West. So hopefully they'll get a good bloom again in California this spring. Probably not to the extent that it was last spring. Maybe over the Colorado Rockies too. Kind of dry in Michigan. I was kind of thinking about going to Michigan for a few orchids next summer, but if it ends up being a dry winter, I don't know if I want to end up doing that. So here's some websites used. They're on this slide and the next slide. And that pretty much brings us to the end. Are there any questions online or anything?
No.
Sure. Rich.
Okay, well,
Mm-hmm.
Well done, Pete.
Oh, there's no way I can guarantee a clear spot there April 8th. So what I would think is when it gets to be yeah, that's definitely better. So when it gets to be late March, I would start to look at this 8 to 14 day temperature outlook, like the last week of March. And they also have 6 to 10 day as you get closer, and then try to figure it out from there. My suggestion would be to be prepared to drive. Be prepared to drive hundreds of miles, unfortunately, just because April's fickle. But if it is clear, there's a lot of cool sites like Sand Prairie. People have mentioned, Giant City State Park. You could do like Sand Pond Conservation Area. There's all different sites. I know more Missouri and Illinois than stuff like Indiana and Arkansas, unfortunately, though. Miguel, did you have a question? Okay, thought I heard.
No, Pete, I just said great presentation, sir.
Oh, thank you. I appreciate it.
And I appreciate the tips for photographers and astronomy and astrophotographers. Very, very useful.
I hope it helps. I mean, your astrophotography is amazing. So.
Oh, I'm still gonna be calling you every now and then.
I like it. That's a great question. I do not know how much. I know this is really dependent. Plants are really dependent on this, but I would have to imagine it would trickle up the food web to birds too. That if you're going to have like a cold fall, I would think. I mean, I shouldn't say have to think. I would think that the birds would generally start migrating earlier. Let's see. I would think that if we day-night cycles, really? Okay. Franz? Okay.
when it comes to what is, if you show that, what was it 30 years ago, 100 years ago?
Oh, okay. Well, I would say generally, yeah, I didn't show that. I mean, with climate in the eastern US, the eastern half of the US, which we're in, it generally has been warming up, probably about a degree the past century. And we've definitely been trending wetter. Like I would think in the 1950s that our precipitation averages might have been more like low to mid 30s, 30 inches per year, 30 to 35 inches. And now we are like 38, 39 inches a year on average. We're definitely getting wetter, even though we're in a little bit of drought this year. It does seem like Missouri is kind of returning more to the forests as we go out in time. Mm-hmm. Mm-hmm.
What do you think?
Summer solstice, yep.
There you go, Russian cheese. See, it's hearing us. I think we want to do that.
Yes. Yep. Mm-hmm. So exactly like in our summertime, these the poles will be getting a lot of solar radiation, and it will be similar to the tropics. The amount that they receive because the day is so long is similar to the tropics. And what happens is in the night in the southern hemisphere, then once you get below like 15 degrees south, then they are at a deficit. And so pretty much almost most of the southern hemisphere is at a deficit compared to the northern hemisphere that year, that time of the year. So it cools down for most of the hemisphere. It's just that down in the tropics, down to about 30 degrees south, there's going to be good circulation of the atmosphere, so it'll still keep the air is going to still mix some of that warm stuff south. But once you get past about 30 degrees south, then it'll get really cold. So yeah, that's a great observation. In the summer hemisphere, most of the hemisphere is like the tropics. It becomes really warm.
I heard something years ago. Best places to spend the summer in the different regions. And in the Northwest, it was Buffalo, New York.
Northwest, huh? That's a while ago. Okay. Yeah, it's just such a cloudy climate. I mean, you can see there's your annual clear sky days, and there's Buffalo. So the summer might be nice, but yeah, other seasons too. Mm-hmm. Yeah, I've never been in kind of that lake effect belt, but that does sound it'd be interesting, I think, to spend maybe a winter there, and not really have to move around. Yeah, you can see Buffalo is not the clearest climate in the US.
Really fast, it gets down to minus 40 degrees. There's one man up there that there's shorts and later long and basically.
That's when you get below -35 Fahrenheit and you boil up a pot of water and then you toss it in it. Yeah, crystallized, come down. Yeah, you have good odds there. Huh.
The water, wet water. Hang out with.
Since you told us about snow and saying insignificant.